so much for coming to the AI Huddle. If you don't know what AI Huddle is, it's Google Cloud's open, collaborative, and developer-first forum with Google AI expertise. And our whole goal is to connect Google AI expertise with developers and customers who are running their AI workloads, preferably on GCP. And the goal is to have conversations with you around AI, what problems you're trying to solve, and basically learn more from your experiences and have a dialogue, have an exchange of ideas and thoughts. So with that, I will actually let me do a quick intro of speaker for tonight. Okay, I got your pitch. Okay, cool. So speaker for tonight is Yuhan, who's an engineer in Google Cloud AI. Yuhan, let me take out. Yuhan is a developer program engineer in Cloud AI since 2017. And previously he worked as a machine learning engineer and full stack engineer at multiple startups. So with that, I will hand it over to Yuhan, who's going to do a deep dive in Tensorflow topic.
Thank you and welcome. I would like to talk to you a little bit today about how to use TensorFlow in Docker. It's not a new topic. I suspect many of you might already be doing this for your workflow. If that's the case, there might still be one or two things that's interesting for you to hear about today. And I made this really clear that I'm really talking about how to run machine learning workflow more efficiently in a sense slightly different from the usual when people are talking about your machine learning workflow's efficiency. I'm really talking about your own development cycles. I'll share a few personal stories in my previous machine learning work and how that impacted me and how I wish I had used Docker with a better habit, and that'll probably save me a whole lot of time. Just in case maybe some of you have not used Docker before, maybe heard about it, but haven't gotten into it just yet. Docker is really all about dependencies. And in one word, just dependencies. And that's a way for you to declare and pin dependencies in a really, really nice way. How does that have to do with TensorFlow or machine learning workload in general? I would like to sell you this vision when I think about a project that's been done. There are just three components I usually think about. One is the developer, that's you, who is usually writing the code. That's the code in one of the corners of the triangle. But that code doesn't just run in a vacuum, but rather it runs on some kind of infrastructure. There's some environment that supports the code that can be run. And that environment, in turn, is being set up by you, again, the developer. And so that's triangle here. Now, if you are a single developer on a one-person team, that's yourself, working on a single project, a single code base in an always consistent environment, say your laptop, then probably you don't need Docker, to be completely honest with you. But any moment, if any of these three corners, I guess, of the triangle changes, Docker might help you in some ways. That's sort of the pitch that I have tonight. So you can imagine, how can the developer corner change? Well, you might need to share your project with someone else on the team. If you're working on a multiple-person team, maybe you need to hand it off to your engineer if you're in the role of a data scientist. Or the code, you might be working on multiple projects at the same time. You might be maintaining and, in fact, improving more than one machine learning-based services in your production environment at the same time. Environment, you might be doing experimentation on your laptop in maybe notebooks or some other kind of configuration, and you do want to move it to the cloud somewhere for serving or for larger scale training. And so that is when you'll have to change the environment angle of the triangle. And so whenever any of these changes, you might be in a situation of dependency inconsistency, and so that's when Docker might help you. But I do want to point out that Docker isn't the only solution for any of these problems, right? There are other ways to deal with this. For example, normally for users who do need to work on, for developers who need to work on multiple projects in the same environment, be local, on your local machine, usually people will go with virtual environment, say in Python. And most programming languages nowadays have some form of dependency management tools for you. So that is sort of handled. And environment as well, there are many different ways to migrate from one environment to another without all kind of headache that I hope to tell you a little bit about tonight. But Docker happens to be a sufficiently flexible and powerful tool that handles all this in a consistent way. And so the kind of good habit I'm hoping to promote in this session is that with a fairly small amount of overhead, when you set up a project and when you work on a project, you'll be able to remove some of these obstacles later on if you foresee that there'll be a point in time when I need to hand this project off to someone else, or even just start collaborating with someone else. Or if you see that at some point you want to smoothly switch between different projects or move to different environments, you might consider start out with sort of good habit. And this is really general about software development projects and not specific about machine learning workload. But I want to say that a lot of times machine learning workloads have this hidden dependency that people don't talk enough about, in my opinion. In my own example, at the previous team, I had worked on machine learning project back to back. Back then we used scikit-learn. And I deployed one model, so great. And then when I move on to the next project, I thought I would be upgrading my scikit-learn version and then to use a new feature which I needed for the next project. So it saves me a lot of time. Only when I deployed that, I realized that it was breaking the previous project because the previous project could not be loaded into a newer version of scikit-learn. And I don't know if it happened to you. For TensorFlow, I had the exact same issue as well. I had old checkpoint trained with older version of TensorFlow. It just does not load for me anymore with a newer version. And so you can imagine if you're a data scientist working in this situation, you might have deployed the whole model somewhere already, and the requirement has changed or the needs has arisen so that you need to improve that model. You would like to load the old checkpoints so you don't have to redo all the experiments. It doesn't work anymore because you have updated your TensorFlow version. So that can be really subtle because these things are really hard to pin down. A lot of times people will go with pip requirement files and say, this is a list of pip packages that's needed. And that's what we did before at the previous team. Only when we realized that we're using a single requirement file for a single monolithic code base, and that's causing problem for everyone who's using the same code base because I'll be saying, hey guys, I need to update this particular scikit-learn version to a fancier version because I need it, and that breaks everyone else's work because they can't use it. And that particular case happened because scikit-learn was making very significant change. They moved a bunch of code from Python into Java backend. And so that caused a whole lot of issues because some interface suddenly disappeared. We do hope that similar things will not happen to you, but if it does, it'll be a lot of headache. And the end result was something like I had to spend a whole month trying to figure out what's the update path for the whole code base so that no project will break. I can still use a new feature I want. Old models can still be deployed to production. A lot of problem. And so these are the benefits of Docker, exactly corresponding to those three kind of changes I was talking about. For consistency, if you want to run code in the exact same environment, Docker helps you do that. For isolation, if you want to work between different projects with very quick switch, yes, virtual environment is super fast too. In terms of switching projects, Docker can do that as well. Collaboration is really the bigger piece here. And by collaboration, I mean a little bit more than code level collaboration. A lot of times you do need to hand off a whole deployable project, a bundle of some sort to your engineer, and then to deploy that to somewhere on your infrastructure. And Docker makes this much, much more seamless because the environment is, first of all, declared in an understandable way. That's really important. And making the results much more reproducible. So I want to, just for the benefit of those who might not have been using Docker for a while, I have a little bit of mini cheat sheet here showing some of the commands I'll be using today for, I think, like in a few minutes, I'll switch into more like a live demo mode and show you one particular workflow. So illustrating all these points I was making here. So the basis of Docker, there's these two things that are often confused. There's a Docker image and Docker container. A Docker image, you should think of that as a software bundle that comes with the dependencies already installed in there. And the container is a running instance of that. So the same image could be run multiple times. So you could have one image being run 5 times, and you get 5 different containers, all running the same image. So think of them as 5 processes running the same code. And so these are some basic commands. You can pull image that people have published. For example, here I'm showing a standard way to identify a Docker image. So GCR stands for Google Cloud Registry. It holds Docker images for you. So you can pull it if people have built and published Docker images. And you can Docker space images basically list all the images you have pulled from repositories. RMI stands for remove image. That's really handy. There will be a time when you have way too many Docker images on your laptop. You might want to remove them. And to run them, you basically use the same syntax. Oh, so by the way, here, whenever I mention repository : tag, that's the same thing as up there. So that whole thing, gcr.io, everything up to colon, is in Docker language, it's called a repository. And after colon is a tag. And so you might be pulling different things, like different versions. And if you have a container that's running, you can kill it. Again, Docker container is, you should think of that as a running process that runs a specific piece of binary, perhaps, or executable. You should think of it that way. Questions so far? Good? Okay, a little bit more. And Dockerfile is really the declaration of how to build the image. We're going to go through a really baby example of that today. And then these next 2 things are really interesting. I'll make some more points in a minute. You can mount value. So a Docker container is a process that's running on a host machine, maybe on my laptop. So what happens is that on the base here, my laptop has its own operating system. And on top of that, it could be running multiple Docker containers at the same time. So those are called Docker containers, processes running on top of the host. And so there's a way to communicate the host and the container themselves. And these are 2 basic ways. One is by mounting a volume. If you want to share part of your host's disk with the process, which is extremely important. I'll get to it in a minute. And another way is to forward the port. So maybe your container is running a service, and by exposing some kind of port on the container, you do want the host to be able to access that from outside of the container. That's how you do it. You will just forward a host port number : a container port number. So it's the same syntax, host container ordering. With all the nice things I could say about Docker, there are a few gotchas. And so one of the most important things, I cannot emphasize this enough. I tried. I have all capital, bold italic font, and in highlight. Everything you do in the container will be gone. Again, will be gone. I've seen this happening to new Docker users and experienced users as well. They've gone into Docker, they feel so at home, and they run all kinds of download stuff, they install things, and they run code, they save a model locally, and then they exit the process. All that is gone. So the interesting thing is that a Docker container feels just like a shell, right? You can connect to it. It's a process that's the whole environment. It feels like a new computer almost. You can do all kinds of things in it. It even has a file system in there, except that file system is not persisted. The moment you exit the container, everything is gone. Well, unless you were doing things carefully and connected the running container with the host in the first place. That way, everything you are writing into the disk in the container does get written to your host disk. That way, you'll not be gone. And so that's really one of the biggest gotchas. I have wasted hours to recover work just because of this, until I learned how to mount disks. But think about this, there's this downside of mounting disks, which means your package has some additional extra dependencies there, right? So you are mounting a disk, and then you download things, write code happily, but all that code is no longer in the Docker container. So that means this Docker container or image thing cannot be handed off easily anymore, because now it has to carry this additional baggage of whatever code or data or model that you have created on the side. So that's some trade-off you need to think about. Normally, I would recommend doing things with some of the cloud storage on day one, if you can. If you foresee that eventually that's going to be your need anyway, start writing things to the cloud somewhere. That way, you and your team can easily share that. Another thing that's also gone is that you connect it into your Docker instance and then a process, and then you install things. It will also be gone, and then you come on run the code again. Somehow it doesn't work anymore. It's complaining about some package is missing. You said, wait a second, I installed that before. Only you have exited the process. And so here, Docker also provides a really handy way for you to sort of remember to keep the note for that is through the mechanism of Docker file. So every time we are in a container, install something, make sure you record that in your Docker file. That way you'll never be lost, and then anyone can come and reproduce that. Some other gotchas we're not really getting into today is networking. It's a little tricky. It has to do with the port forwarding business we mentioned before, because Docker containers are designed to be, one of the goals is to be really secure. So we don't really want containers to be talking to the outside world very easily for good reasons. And so sometimes people will have struggled with networking a little bit. If you are in a situation when you do have to manage a large number, even just in any case, the multiple containers that need to talk to each other or outside world and the host, that becomes really complicated graph. You might consider using some frameworks that help you do that, such as Kubernetes. There's some other tools out there too. And credentials are another issue as well. On your laptop, you usually just happily connect to any kind of services that you are authorized to use. But in a container, it's usually running in a different identity, right? Remember, that's like a whole new computer that happens to be running on your host machine. You might know nothing whatsoever about your host machine's credentials or environment variables and things like that. So there are issues there as well. But we'll probably not get into that today. OK, any questions up to this point? Yes?
What is Docker Compose?
Docker Compose is, I don't know, what do you think it is?
I don't know, we just used it in the morning and I struggled to understand it. Based on the YAML file. But is there like you have separate Docker containers and then?
I have not used that before. I heard of good and bad things about it. That's what I can say.
I don't understand it conceptually. I mean, I can call something or is it like a recipe to create Docker containers?
I don't know. Does anyone know what Docker Compose do for you?
Maybe it's not there.
Maybe not. We can look it up together. There was another question or a comment?
So where do you download Docker containers from? Is there like a GitHub type repository?
There's something like that too, yes. Thank you. So usually pull from typically public repositories, very much like GitHub. And in fact, there's something called Docker Hub that has published Docker images that you can just download. So you can download individual images from there. So for instance, I was just in the suite for TensorFlow session earlier, and then they mentioned Docker as well, and then you can actually go to Apple's TF Hub repository and download the Swift Docker. That way you can run things on your local machine. That's right. So there's something like that. Yes?
Isn't it possible to do incremental updates of Docker images? Because as a team, everybody has a Docker image. But then instead of downloading the whole image every time, is there a way to do incremental updates?
Yes. Yes. So the question was that how do you do like incremental update of Docker images? Yes, when you build a Docker image, it actually has this concept of layers. Usually you usually ignore that because Docker, the software Docker itself handles that for you in saying that it caches, right? You are building an image, which really means you start somewhere, a starting point, and then start adding dependencies to it, which your project needs. And eventually adding your code that has to be executed on top of all that dependency. You're not really downloading everything every single time. We'll kind of see that in a bit. So parts that have been downloaded once will be cached on your system somewhere, and then next time when you build on top of that, it will not be re-downloaded again. Okay? But that's still handled for you automatically. Yes?
So if you require a license to run software inside the container,
Sorry, come again.
if you require a license to run software, where does it reside?
Oh, for Docker or?
Like software inside the container.
Oh, inside of Docker. I think for a lot of times, so I think yes, if you are you're saying using software in the Docker image that has license.
Yeah, so if I give my software for a user to run on Docker,
Yeah, I think at least if you publish things on like a Docker Hub, you have an opportunity to put in your license there. So to specify that.
Once you get your license, you actually just have to open a port, open it up in a container and say, you know, I now have a NAT IP address.
Okay. So the kind of workflow I want to really quickly show today is that how would I go from experimenting locally and develop a simple machine learning model, or workflow rather, and you see, I was trying to do things carefully on the local level already. Even locally, I don't just run on my host machine, but rather I already do it inside of Docker container environment, so that later I can literally lift up this whole Docker and then move it somewhere else. Exactly the same result will be repeated. Just remember that to save my work in a volume. And then I will try to show you how to build a really simple, minimal Docker image. And if we have time, I suspect we might run out. We might show how to deploy this container, deploy this images container somewhere to do training. Okay. Let me exit here from the slides. Okay. So my starting point is that I need to start with something. I need to start with a Docker image that has some stuff that I already need. So I'm just going to use the example I mentioned before. So Google Cloud already published some of this. So I'm going to run a local container workflow. I'm just going to take this because that already has notebook installed for me. So I can run notebook experiments, which I feel more comfortable in. And a bunch of stuff, skip over. And here's a key point here. How do I know what kind of Docker images are out there that I can download? Here's one place where I can actually get a list of one particular repository and see what kind of images this particular repository has included. So I'm going to just run that. And it lists a bunch of them, right? So I see some PyTorch Docker images. I see some R images. I see TensorFlow images, and compiled in different flavors. And so those are packaged environments. I can, is it visible? Maybe let me make it a little bigger. Does it help? Okay. So I can just Docker pull one of those. I'm going to pull the 2.0 CPU image today. So I'm going to copy this identifier here, and sometimes you can add colon with a tag there if you know which tags there are. I'm just going to pull the latest. So in this case, I'll be running Docker pull, and exactly that identifier there. And it's going to use the default tag latest, and it says, it's done. Well, and let me be honest with you, this normally takes a while because that image is actually 6 gigabytes in size. So it takes some time for the first time you run it, but subsequent runs will not require you to re-download that again. So it already saves a copy of that. And then so I can also run one of the commands that was Docker images, and you'll see a bunch because I have been playing with this before, but at least we do see that it shows up somewhere right here, this one here. So that's one that actually I already pulled 3 weeks ago, and its in size is a scary 6 gigabytes. And when I look at this list of images, I was kind of worried, right? Whoa, I have a whole bunch of images. Each one of them listed 6 gigabytes. So I get something like a 6 times 20 of a bunch. But that's not the case. Although so individual images are 6 gigabytes, but they do share the cache layer. And so if they all come from the same base image, that base image is no longer repeated in different images. All right, so the Docker handles that for you really nicely. Okay, so I have this. What do? I'm going to follow instruction here and say, here's the way to run it. And actually run one of the images here on the documentation shows 113. I'm not going to run that. I'm going to run 2.0, and I'm going to mount the volume as well. So let me copy this and then modify it. So I do want to run this command, but instead of 113, I'm going to run 2.0. And I do want to forward the port. If you see the 8080 port, that's the default port for Jupyter Lab. And I want to mount the volume. I'm not going to mount this path local. I'm going to mount it as, I'm just going to mount my current directory. And mount wherever I am in. Okay? I'm going to run it. And by the way, you also see, image not found. Did I maybe not have the right? Oh, I see. I think they changed the name on me. So I'm gonna run now again, copying this to make sure I don't maybe type it wrong. There. Okay, now it just spits out a hash, which is of no use. And somehow I'm returned back to my shell. I can do things now here again. What happens is that because we have the -d in there, it's in the detached mode, so, or daemon, so the image will try to run, and if it exits, it exits. But in this case, it does not exit because the way this image is built, it actually turns on the server that's on 8080. Because of port forwarding, I now can access that service, the Jupyter Lab server that's actually run inside of container through my host, which means my browser can just access that. And this mounting here means it connects whatever directory I am in with the home directory inside of Docker. So let's do some experiments. And I have a couple files here. I'm going to make a fake file. I'm making a new file here called delete me in here, and I'm going to connect to my Jupyter Lab. Localhost 8080. And there it is. And on the left-hand side, I see the exact same three files already showing up right here, including the one I just made, delete me. And so to just prove to you that these are really connected, so just to make sure, that's also a good habit to have, to make sure that I don't really lose code here. I'm going to come outside here. Remember, this shell window here, terminal window here is the host environment. I'm not in Docker there. I'm not in Docker container. But right-hand side, the Jupyter Lab, I'm inside of Docker. So it's another machine that's running in here. I'm going to remove delete me because it says that. So I'm going to come back here and then refresh, and it's gone again. Okay? And so this really validates that these two volumes are connected, one on host, which I know is persisted, and the other one on the Docker container that would have been gone if I were to exit the process. But because we mounted volume, that's okay. And right now I'm going to simulate maybe developing experimentation for a model. I'm going to just clone. I'm going to go into home first. So I see the same file. So this is the home inside of Docker container now. There's another machine that shared the disks. And I'm going to just clone this repo. This TensorFlow examples that contains a lot of community goodies in here. So I'm going to git clone that. Okay, should have done a shallow clone, but it's okay. Okay, we got it. So now I get that thing. Again, if you still don't believe me, I'll come outside here. Oh, it's not done. And I'm going to list files. Now I see the directory examples now has been cloned also onto my host. That's my laptop here. Okay? And there's one particular notebook I would like to experiment with. So let me just copy it out. Sorry, copy. Example. Oh, let me try to make this bigger, see if that's more visible. There. I'm going to copy one of the files out so I can work with it. I don't have to always go so deep inside of the repo. So community, what do they have? English. I'll take this autoencoder notebook and I'll copy it outside. Of course, it shows up right away, almost right away. I opened Python 3 notebook with it. And so I get this code here. Now again, it's running not on my, well, technically yes, it's running on my machine, but it's running inside the environment that's completely contained in a container. I'm just gonna run all to make sure that everything works. Question to this point, by the way.
So the only access to Docker is through a web browser?
There are other ways to access. The question is that how, so the Docker container, what are the ways I can access? I can do it in the browser because I have exposed, I'm running a Jupyter service on the Docker container, and that has been forwarded to my host. There are other ways to do that as well. From my terminal window, I can actually SSH into it as well. Sort of SSH, not really SSH, rather just I can just connect to it directly.
So I could launch a spider onto the Docker image?
you can, that's what you can do. So, for example, you can kind of see a little bit here. Here, there's this shell that's running on the Docker container. You can do it from terminal directly as well. So you can, if you know what is already installed on the Docker container, you can do whatever you need on it. Yes?
The Docker container now capable of supporting the GPU.
Yes, I think so. I think, well, what do you mean?
Like when I run my, Jupyter Lab with Tensorflow, if I downloaded the Docker container with GPU.
This is TensorFlow GPU, right? Yeah. Yes, but there's some work. So you're talking about sharing other kind of resources, right? Mounting a volume is sharing the disk, that's a file system with Docker container. And sharing other resources can be a little problematic. I think GPU, yes, is something that I'm sure is a solved problem because I know that Kubernetes can do that.
You just need, the NVIDIA GPU I work for NVIDIA, you just need to install the Docker runtime from NVIDIA. So it's just a little runtime library that you need to install
Under strictly Linux or other kind
Yeah, we only support Linux.
only Windows.
No, we only support Linux. There are ways that you can do it with Windows, but NVIDIA directly only supports Linux as its GPU password.
Thank you. Also, there are other kind of resources you might want to share that's also very problematic. For example, you might try to share the microphone of your host with Docker container. That can be very hard to do. So, but I mean, there's a path forward to be sure. Other questions or comments? Yes.
How do you get a shell container when your prompt is still like local because it didn't change?
You mean the one on the right? The one on the left has not changed. The one on the left has not changed because I was running in a detached mode. So that Docker run command, let me go back here for a bit. So it was saying, run it, and then let me go back to my own shell, right? So it has not changed, right? I'm still in my own TF in Docker shell, still on my host machine, right?
How are the files making inside the container?
The files are connected through this the -v command. This -v here says, right now, this directory I'm in, where I run Docker run command, I want this directory to be shared with the home directory inside of it. And so it's like two different processes somehow have a shared memory of sorts. Okay. That's right, exactly. So now everything I do inside the container will be persisted on my host disk.
When you want to reuse images again, how do you mount it, unmount it? You have store systems essentially?
Sorry, what was the last part?
When you want to use it in another container, you just unmount the file system and you
It's the question that if I use another container and they're sharing the same volume, that still works because that somehow goes through the host. Probably not recommended though. So unless you are fully in control of all different containers are doing with the mount, but yes, it does work.
your home directory set up.
Right, and then you can mount this exact same directory on my host with something else with another container. That's right. And so that will be physically still the same disk, but then the containers, remember, they are really just processes. They can access those at the same time still. Except when you're inside the container, they will look like some local directory.
But anything which is run in that container with respect to the file system doesn't persist, right?
That's right. So that's why it's so important. That's why, so things will not be gone. Exactly. Yeah, kind of depends on what you're trying to do with the things, right? Because then you start in a situation where you might have race conditions, or you think about, do I need to lock this file so that this container is accessing it? Well, what if the other container is also trying to do something about it? Things like that. But yes, in principle, you can do that. But then you need to think about coordinating this. That's what I mean. If you have full control of what the containers are really doing, no problem. But if you're not sure, right, you might have something that say running training and writing output checkpoints to a disk, and then have another process doing evaluation, for example, something like that. That just totally makes sense because you will not have like erased write conditions. Yes.
Can I use Colab to talk?
Colab.
Colab.
When you say Colab, you mean like this Colab? This Colab. Depends on your use case, I think. So in this case, I think the Colab instances are gone after a certain amount of time, so you need to somehow put things in different places. Can be a little harder to install dependencies. For example, like here it comes with specific version of TensorFlow that you may or may not want to use for your project, things like that. So different limitations.
So I have a question. With Colab, you can connect to a remote runtime. The remote runtime
Oh.
on your laptop can be a Cloud VM parent Docker image.
In that case, you can, right? That's what you're saying,
Yeah.
right? Okay. As opposed to the runtime that's provided by this. Cool. Thank you. Other questions or comments? Okay. So where we were was I was going to run this autoencoder notebook, which I did click run all. So I just scroll down and see, okay, they ran, they seem okay, and then scroll all the way down to the bottom. I do see some outputs. Okay, it did run through training for 20 epochs and show the nice graph here, and it's autoencoder, so you try to produce reconstructed images of these empty digits. So great. Okay. Okay, now, right, I'm going to pretend that I work on this code, and then now it's time to hand it off to someone. What do I do? I'm going to actually do a little trick here and try to make this actually a Python script that's runnable. I do want to keep the notebook as a source because it's easy to experiment with, but I don't want to manually copy code out, so I would use this tool called mbconvert that many of you might have used. But in this case, I think I do want to be a little careful here. So when I'm experimenting, I'm going to run not 20 epochs because that could take a while. So I'm going to run just 1 epoch, let's say, just when I experiment. And then in the graph, I'm going to show, or maybe 2 epochs, why not? Okay. But then when I'm doing this, I'm kind of getting concerned because this is like a temporary change. Right? I'm not going to keep it as 2 epochs as hard coded. So I'm going to come back up here and try to introduce a parameter here. I'm going to go all the way up here, right below the from future import, because that must be the first thing. I'm going to try to make this into argument that can be passed into not the notebook, but rather the Python script that I'm going to create with the notebook convert. So I'm going to do something like this into import parse, and then I'll have something like this, and then I want to just introduce an epochs parameter that I can change. So I'll just have something like optional epochs, and with type of int with a default of say 2. Okay, and so once I have this, and after, of course, I want to really parse the args. I don't remember if it's known args or maybe just run it and then rely on knowns underscore args. Okay, and then I'm going to parse that. So now this args variable holds epochs at least, right? So if we run this, just to double check. Args will be this namespace that has this thing called epochs, that's 2. And later I can pass in different numbers in the parameter. So I'm going to go down here to change those things now. I'm not really interested in training 2 epochs until, I mean, once I'm out of the, pardon me. Once I'm out of the local experimentation mode, I'm going to run more epochs. So I'm going to have args epochs. Okay? And replace the other 2 as well. Args. Okay. Okay, so that looks okay. And I'm going to try and run this after I do notebook convert. I'm come out here, clear it, and see I have copied a copy of the notebook out there. And I really don't like to keep 2 separate sources, and so I'm going to call this IPython mbconvert. And I need to specify what kind of output it is. It does a lot of interesting things. You can turn it into Markdown. You can turn it into HTML. Or JSON is, I think, the basic format. So I'm going to turn it into Python, of which file, autoencoder.notebook. Okay, write something. right? It says writing a number of bytes to autoencode the .py, and I see that file showing up here. Right now, it's showing up here. Okay, and so now I can run it. I'm going to just run Python 3, autoencode the .py, and now I can pass in the epoch parameter. Let me say, let's train. Remember, my default value was 2. I'm going to train like 4 epochs right now. And now it basically runs in some ways one cell at a time, but there's a little gotcha here if you have not used notebook convert before. If you use the magic commands inside of the cells, it does not get converted, and so those will not be run. Okay. Oh, my bad, because args actually, sorry, let me go back and fix that. Because I used parse known arguments here, and then notice that this args here is really a tuple of things. One thing is the parameter I really want to pass in. The other thing is this thing that notebook just carries along with it. That's also part of why I had to use parse known args. So I'm just gonna ignore the second part of it. I run this again. Args now is just 2. Okay. I'm going to run the same command again. Convert it. So actually, let me make it clearer. Here, I'm going to run the convert, which again takes the current state of the notebook, make it into a Python script, and I'm going to run it. And Python 3, autoencode the .py. It will be after the conversion. I'm going to pass in epochs 4. Okay. Oh, and sorry if my screen turns yellow. It's the night shift coming on. Okay, so now it's running, and this has a little bit noisier printout here, and it's running first epoch, second epoch, and so on. Okay? Okay, so that's great. So now I have a Python script that I can supposedly run wherever I want. Okay? Not quite, right? I do know that this Python script runs really well in this Docker container. That's sort of the mental model here. I have a host somewhere. I have a bunch of other machines I might be able to use. But I really don't know if this script runs anywhere except for this particular container. I know that it runs well here. It trains through for me. It has a little bit issue with showing the images because I'm in shell. Okay? There's another problem here. It also does not save the model, which I neglected to do. So let's go through this again. I had an encoder, a decoder. I want to save the model. So where was the training loop? Here's the training loop. I do want that at the end of training, right after the for loop, I'm going to save the model. So I have the model save, save the model for maybe save format is TF. I'm going to save that as the TensorFlow saved model format. Okay, as opposed to the H5 format. Okay, so I have this, and then I will say, there's a little bit of gotcha here. If I just run this, it will complain that I cannot save. Let me just show you. I'm running this notebook here, and then I try to, I have a data set. If I just try to run the training loop, it's gonna say I'm missing some stuff. Because it turns out to save that as a TensorFlow saved model format, which is much better. Sorry, which is really good in the way that it's much more portable. You can move it to other, it's more self-contained. So you can deploy that for prediction more easily. But it's complaining now. It says it doesn't know, it's saying that I should call something like this, call set inputs, because to save that enough for me, it needs to know what the input shape is. Luckily, it's not too difficult. The error message here is really helpful. It tells me I should call set input. Inputs, I'm just gonna pass in the whole input. I think that's called xtrain. And then run this again. Again, only 2 epochs. The default value here. Then you will save. Pardon me. You will save a saved model format, a saved model for me. And it's gonna show up on the left side here. Refresh. I see saved model directory. And again, because we mounted the volume, and so that also exists outside now. So I come back out. Again, that's in my host machine on my Mac now. I look at this, I see the saved model directory. And I see what's inside of it. It has assets, it has saved model. Maybe just do this. Never mind. So it has the variables and assets already saved for me. Again, even if the training process was running not on my laptop directly, but rather inside this container, they could share that. Okay? But let's see what happens if I were to try to run the same command outside, right? So I also have the converted notebook and converted Python script right outside here. What if I try to run it? I can do Python 3, autoencoder.py, and it's going to fail right away because I don't have any of the dependencies that was installed in the container, right? So this is literally the same script because on the shared volume, but running on different machines, that's the environment, the different environment or changing the environment bit that I was talking about, and it has different output, right? So in the container, that's a much more secure and consistent environment. Now I know this script here definitely runs. If I hand the script to someone else, it will not work, but if I hand them the script along with the Docker container, it will work for them. Okay? Question so far? Yes?
Would you recommend sharing a directory that's kept in Git so that it's easy to synchronize?
I would think so. So the question is like, maybe we should share a directory. Yeah, so in some cases, if you do have, your team has infrastructure set up so that you can have a shared drive or something like that, that would work pretty well. In one of my previous teams, we did have, we have everything hosted in the cloud, and so that way everything will be already shared by default. But that has other kind of issues because race condition again, so, or versioning, right? Other questions or comments? Yes? Oh, in this case, I use save and not save weights because I was saving as, is that a question? Like you save weights, I suppose? In this case, I just use save, but I specify the format to be TensorFlow, so that already has variables in it, like this file here, over here.
Do you already have like predefined weights though that necessary to run this notebook?
Predefined weights or? No, for this notebook, I think it just randomizes the initial weights, and it's already meant, right? But then here it saves the weights after training. So. Right, including model weights. So the save the model directory is really nice. This whole tree here. If you hand this whole thing off, you can really deploy that, and other people will be able to serve the model very easily. But it will not be as easy to pick it up and continue your experiments. That's sort of the gotcha here as well. So, it's very self-contained. It has the structure of your graph, that's the saved model.pb, and it has the weights, the trained weights. But if someone wants to actually load that and then continue with the experiments or modify the graph in some way, that's a little bit trickier. So.
You also have a data set in your container as well, or is that in the mountain point?
Thank you, good question. So, how about the data set? So in this case, in this particular case, there's one step here where it downloads the data set. Where do I have it? I think it's just mnist in this case, right? So later we can see it as well. So there's a part where it downloads data set, but it just so happens that the downloaded data set lives on the container, but not in the home folder, but somewhere in like a temporary directory. So it will be gone once I turn off the container. Okay? And so this is a small thing that you need to keep in mind. If you mount value, only the volume that's being mounted will be shared, otherwise not. Yes?
Thank you. So if I want to load the model and train further epochs beyond 2 or beyond 4, I would not be able to do it in this format. Is that right?
You still can do it, but that's why we actually change, allow the epochs parameter to be passed in from outside. So you can actually change that. But right now it looks like I cannot run it on my host, right? Is what you meant? Or?
No, so I want to train further epochs on it, and I want to continue from where I have trained it already.
Oh, with saved model, I think you will have some trouble with that.
All right.
It's doable, just a little bit more work. And so in that case, you might want to just save that as a checkpoint.
Okay.
Then it's much easier to reload it.
Got it. Thank you.
If you want to continue the experiments.
What does the checkpoint save exactly? Just the weights or more than that?
It also saves more than just the weights. But somehow interface is set up so it's easier to reload back into TensorFlow. So. it does save the, well, not the training data for sure, it does save the weights and the model architecture, so the graph itself as well. But it's in slightly different format. So you should really think of the save the model format as a sort of a serialized format. So that's transportable to other places. But for checkpoint, you still need to, because they serve for different purposes. For checkpoints, usually the purpose is to resume training. And so you do need a copy of your code where
So a checkpoint is a runtime status of model being trained?
yes, if you set things up. So I'm a little concerned about saying that it's the runtime status of that. It's not everything though. So in some cases, unless you set things up, some of the layers might lose their parameters and things like batch norms, it carries some of the hidden parameters. Normally you will keep those as well. But yes, it's sort of like in the middle of training, what's the state right now? So that we can continue later on. And save the model is more of, all right, I'm done with training. I want to save a copy that I can give it to someone else to serve. And that's good for that purpose because it's much faster than reloading from a checkpoint, and the serve is very slow. So they have different purposes. Okay? Other questions, comments? I do want to have at least 5 more minutes of your time, or do we go on until 8 o'clock or 8:30?
8:30, yeah.
Good, thank you. So we can go a little bit more. I do want to show you the Docker file at least, right? So we've done all this work. What for exactly, right? Unless it's good to the point when we have a package that we can hand to someone. Okay, so this is great. Now what? I have something that I can run, but only in this specific container, but right now they're so separate, right? I have this container that happens to be running on my machine, that's great. But then this script here that lives outside cannot be run, right? Cannot really stand alone because I have cut a connection between the code and the environment. I have the Docker file already built, so I'm gonna show you. It's called Docker file, no surprise. Okay, it looks just like this. It's not very much. It says, I'm starting from something, right? That's the base container, which happens to be the container I was running. Sorry, that's the image just running as a container that serves the notebook, right? So that's where all the experiments was happening, the notebook, the Jupyter server. And when starting from that point, let me copy this code here. Copy this thing that's the real outcome of your hard work, the thing that it runs. So then these two together completes the bottom edge of that triangle I was talking about. There's a code that works in that environment. So now this is a pretty complete bundle that I can hand it to anyone now. They can just run. And I'll say, okay, so this is the run command that says, every time when I run this container which I'm building, on top of this other base container that I had before, right? I literally took the container that someone else published on the internet. I downloaded it, do some experiments, and created a piece of code that can run on it. And then I say, okay, now I'm going to build something on top of that that includes my work now. Okay? So I'm just going to build it. So I'll say Docker build. Good habit here. So when I build Docker, I should always use a tag. I'm just going to tag it like GF world. Why not? And then I put a dot here, which means the current directory, because I need to specify the, what's the word, context when you build a Docker. So that means everything in here is fair game. And so that basically specifies, these are the files I might be interested in when I build my own Docker image for myself or others to use. So this dot here really is the current directory. And you will look for, in that directory, a Docker file, which I have, and then build it. And so I'm gonna build it. You will, I hope it doesn't download the thing. No, it does not. Okay, so you see, it does not try to download this whole 6 gigabyte monster here because I had downloaded that once before. And it's all this, that's why it took such a small amount of time. All it does is literally copy this file into it and specify an entry point, sort of like the run command. Okay, so now if I clear it, I run Docker images. Remember, this lists all the images I have here. I should see the image that's called TF world. It's right here now. I just built. Okay, so it has very little really. The delta between that and this other Docker-based image that other people publish. Is the only difference is just that one file that we created and entry point specification. Now I can run it. Now this is an image that's packaged with the correct dependencies in place. Let's run it. So I'll say Docker run TF world. And what will happen is that it will load up this image, my new image, which again has all dependencies because that starts from something, and it'll try to run that file. When I run it this way, it will just run it with, pardon me, the default parameters. So you should train 2 epochs because that's what we said. And now you see that it's downloading the data again. So every time when I run it, I will have to re-download that because that was not part of my Docker file. So if you want, you will do something additional here in the Docker file and say somehow download training data, perhaps in some way, so that you don't have to always re-download it. And then now it's starting out again. The environment is actually this other thing, this Docker container that happens to be supported by my laptop as the base hardware, if you like. So you train 2 epochs and done, right? So that's exactly what we expected. And I'm running into the same, this showing the picture, showing the graphs issue. And what if I want to train more epochs here? Maybe try 3, so then you should run the same thing again, but now you'll notice that you'll have to re-download it because the previous Docker run command has exited already. And so everything else is gone. The downloaded data, the saved model that was in there is also gone because I did not mount volume. Right? Notice that here when I say Docker run, I did not mount volume anymore. So whatever is created in the process of running the container is totally gone now. This time around, I just trained 3 epochs. Any questions, by the way, or comments? Okay, so you train 3 epochs and it's done. And I'm not sure why it's not printing the error message anymore. Oh, it does. Actually, it's up here. Okay. Yes.
How much of a performance hit you get using Docker versus running Maven?
Performance? I would say just by the way it works, it should be slower because there's additional layer of communication that's going on. But I don't have hard numbers to say that how much slower it is. I haven't experienced too much of slowdown myself, unless there's a lot of communication between your container with your host or your container with other things. Otherwise, it's a whole process that's running in itself. Right. So if you can somehow limit the networking or disk I/O, I don't think it should be too big an issue. Yes. Right, which you already have maybe on your host machine, let's say?
Yeah,
or so.
Maybe I have to, so then I have to give the checkpoint separately and the Docker container that image separately. So.
You could set things up this way. So a couple different options, right? If you already have that on your host machine, you can choose to, depending on your use case perhaps, you can choose to copy other stuff in here. So in the text editor here, I could say something like, I can copy checkpoint and into also home directory. In that case, whatever you have currently at the time of building the image on your host machine will be moved into it. So that's one way to do it. That way it contains a copy of sort of your starting point. Another way to do it, if this does not serve your need, you might again mount volume. Maybe sometimes you run it on, but then again mounting volume means you need to remember to carry that mounting volume with you if you want to move it somewhere else. So this trade-off here. And on that point about changing the Docker file to do more things, if you have other dependencies, you might also run it here. It's fairly flexible. It's literally like you are inside of a shell, except you need to tell it with a special keyword, maybe I have to run pip install like a TensorFlow data set, for example. Something like this is not already in the image, but somehow you want to use it, you can just run this. only one time. The first time when you build this image, you will have to literally run this for you in that Docker image, and then just freeze that, and it will be there forever. Questions? Okay. Let's see. I have a couple different choices I can go from here. Let me show you how to run the same training somewhere else. Right? Going through all this work, there's a purpose for it. The purpose is really that I really don't want to train for 200 epochs on my laptop. Also not in a Docker container that happens to be running on my laptop, right? That just doesn't make sense. I probably want to train it on some kind of cloud services. And so this is a whole package that you can literally put it and give it to some cloud services that will train for you. But there's a gotcha there, and everyone should think about before you really do that, in that where is the output gonna go, right? Like locally, if I mount things carefully, running on my host machine or inside of a container doesn't matter that much, as long as I remember to mount the volume, right? The output will be on my laptop still. But if you're training in some machine, that whole machine will be gone. There's some machine in the cloud. And so you need to remember to make the changes properly. So let me actually just quickly add in a couple of lines of code to make it happen. I'm going back to this notebook here. Remember before we add in the arguments, right? So to make it more flexible, we allowed ourselves a number of epochs, which, assuming I'm going to use some cloud compute resource, I'll train 200 epochs instead. Let me add another one. I'll say model directory. Default to just local, right? So something like this. Okay. What's I'm gonna do is that you will, a little bit more, and I need to. Now that if I run this, you will have the args will carry that as well for me, model directory, or whatever I pass in at runtime. I mean, pass different things, right? By passing things, I mean something like this. Remember, we were allowed to pass whatever on the left-hand side screen now. I can pass in additional parameters there, as if I'm just running this Python script. I will just remember that. Why do I want that? I want to write. Where am I? I'm trying to save the model. There we go. I'm trying to save the model to a good place. Okay, so I'm going to do some path join here. And I have args model directory, and I'm going to, in that model directory, have a saved model directory that contains a saved model. Okay? Let's actually see how this actually makes a difference for us. I save. I go out here and convert again, because until I actually convert, that change I made exists only in the notebook. That's a single source, right? So the whole thing with this notebook convert is that. Okay, it's really quick. So it's done already. And so now my Python script outside of the container on my host also has been changed. But remember, that Python script doesn't run, so I have to build again. Doesn't run on my host assist, right? So even if it has changed. Right, so it has just changed a few seconds ago at 7:53, but so it contains the change we just made of adding in this where to save it, but it doesn't run until I build it, right? Again, reminding you what happened here was my host machine simply doesn't have dependency to run this script. But when I build the image, I can. So Docker build again, tfworld dot. And oops, I think I kept the install TensorFlow data set, so you could take a couple seconds. So you'll try to install TensorFlow data set now. So you can install it. So if I had used that in my training script, now it can be used in this environment as well. And then you successfully built, forget about the red, don't worry about it. It does copy the most recent version of that now. So we can do this now. So check, I have a bunch of stuff I'm going to run. Docker run, what's my Docker run command? Docker run, and we can now additionally pass in the different model directory. I'm going to call it output, and then run it. Now it's running this updated script that has this additional ability or flexibility of saving its saved model to somewhere that I specified called output, and let's see where it goes. It could be gone, actually. Now when I think about this. Any questions or comments while we're waiting for this? Yes?
So if I submit my job in a container, let's say it's running on CPU, and I want to have two slaves going to the GPU, for example. Within the container, how do I set it up?
It's a little bit more work. Then it has this networking issues here. So that's right. So you might. To me personally, it feels like too much work to figure out myself. So I would just try to go to things like Kubernetes that already has networking sort of figured out for me. And also because I'm additionally lazy in that aspect, I would just try to find cloud services that already have those things set up for me. So I think that multiple cloud services do have similar things already. So you'll be able to say, I'm going to run my main script on the master, just use other GPU machines for workers. I think normally those things should be handled for you, and the data scientist, such as yourself, shouldn't be worried about that. That's my recommendation. But if you have appetite for that, you might try to figure things out yourself. Okay, it does not save here because I did not put it in the correct place, right? It's running in still not in the home folder. Yes.
So is it possible to tie the Docker build to the mconvert command?
It's possible to do what?
Like every time I do a mconvert, the Docker will get built.
If every time when I do a
Every time I create the Python script, the Docker build will get triggered.
every time we create, it gets triggered. Maybe not. So you mean like the md convert command?
Yeah.
I ran. Not automatically, unless you set it up into a separate script that orchestrates all this. So not automatically. But I think you make a good point. Over time, you can do this multiple times, right? Every time you make some changes, you want to test it outside on the host. You probably have a bash script somewhere that runs inside those commands. You'll say, run md convert with mounted directory, and then rebuild my image for me and run. So eventually, you'll never do that. So just take away all these manual steps. Okay, now this time I do things slightly differently. This time when I ran the command, I selected home/output as the model directory. Now remember, home directory is mounted, and so it's connected to my local directory. So I expect to see. Oh, I expected to see. Oh yes, I do. I do see. I do see the saved model directory now. No, actually it's not, right? It's no, that's from before, isn't it? Right, I ran it before. Then I'm not sure why it didn't show up.
You didn't mount it. You didn't mount it.
Oh, I did not mount it when I ran it. Thank you. So it's. Thank you. Just make sure everybody also saw that. This mistake I made here is the gotcha, number one gotcha. Apparently, I still don't remember myself all the time. I did say that, yes, after your work is done, save the model to somewhere, but that somewhere is gone now because I didn't connect that with the host machine. So let's do it again, but it's maybe with a fewer epoch, so we don't wait for it. But in the run command, I should mount it. And mount again, the syntax is that host directory : the container directory, so like this. Oh, sorry. I also do want that to go into home just to be sure. There. Okay, any other questions? Yes? Oh, I just meant it's a name of directory to put, right? Taking a look at the code here, just to clarify that point, maybe I too quickly did that. So here, the output is passed into us this argument here, which is used as the prefix of the path to write output to. Okay, so it's trained one epoch, as we specified, and now I see this directory called output that has the thing that's just created. Right, so it has, inside of it, there's only one directory called save the model because that's what I told it to do. I had whatever you are given as a model directory, create another level called saved model, and that's the saved model bundle there. Okay? So it looks like this now again. Okay? Now, while we're going through this, once again, backtracking, the reason why we're adding this additional power to the Python script is that so I can save it to wherever I want now. Now, imagine if I had access to some cloud computing resources, I can just say, run this container for me with whatever resources you have, but write the output to a, like some kind of cloud storage solution. But before you can do that, so I do want to show that real quick. Maybe at least 5 more minutes, and then we can go into just more general Q&A. Is that I do need to push this image here, right? So once again, Docker images, all these images are things that exist on my local machine only. In particular, this thing here, this package here, that now A can be run wherever that can run Docker. B accepts an epochs parameter, so I can specify a large number of epochs if I wanted to. And C, it also accepts additional model directory parameter, so I can save the output to somewhere else. So let's say you should try to push that. I'm going to use Google AI Platform's training, but only because I have access to that. And I have a cheat sheet here for myself. I remember the command of how to push an image. Okay, here's what I have to do. Test push. Okay. A little trick here. I need to rebuild it with a different tag. I think different services do things differently. If you use Docker Hub, I think you need to use their tooling to push, and then you specify your tags different ways. I'm going to rebuild the same image and call it AI Things 101 TF in Docker. Because why not? I'm going to build it. Oh, I'm in the run directory. You see what's happening here is that it's trying to look for a file called Docker file in where I am right now. But remember, I just changed the directory into the output directory, which doesn't have it. Right? It has only a save model. Do it again. Build with this. And that is going to be a new tag. Luckily, it's very quick, again, only because literally I'm just renaming it. Okay, now I have this new image here. Just double check that. Images, I see it somewhere up here. This is a tag. Now I'm looking for something that's created just seconds ago. So let me change it on the, oh, oops. Docker 1. I want to see the thing that I just created. Okay, so successfully tagged. Docker images, do I see it? Do I see this one now? Oh, see, I was a little worried when you said 8 minutes ago. Why did you say 8 minutes ago? Because nothing has changed in the past 8 minutes, right? So Docker handles that for you as well. If any of the files that you copy into the image has changed, it will rebuild that for you. If nothing has changed, it will just use the cache. So you don't have to think about, oh, have I just always run it? You will get the most, the current state of things. If nothing has changed, you will not wasting your time doing work either. And then I have secretly on my cheat sheet here also the push command. There's a bunch of other stuff just so that I can access that, but feel free to ignore that. I need to authenticate. No, I don't have key file. Let's see if that works still. It might work just the same. And I'm going to push. I'm going to run Docker push this image here to somewhere. See that now this tag here, the tag I use, which looks really long, right? Before I just called it TF world. That's super easy to remember. Why do I need this long and messy gcr.io and so on? Because it gets parsed. And so gcloud command knows where to put that thing into. Just to be sure, let me push the one that says 1. No, let me just push the same one, just so it doesn't take too long. Okay, so it's gonna push. Oh, and I'm afraid it could take some time because I also did install TensorFlow data sets just now, which is additional thing to upload. Okay, pushed. And you see all this bunch of stuff here, layer already exists. What are those layers? Those are the base layer, the 6 gigabytes of stuff, which I previously had pushed before, so it doesn't get repushed because there's no need for that. And Docker internally is using these hashes to identify individual layers, so that it knows, oh, I see this hash here, let me look for in all the past pushed layers before. If something already existed, there's no need to, they can just continue building from there. Okay, so it's pushed, but where is it? It's pushed to this directory here. It's on Google. So I'm in a console now for GCP, and I have container registry. And for this project, I have a TF in Docker repository, and it has a few images, and then the one that we just pushed is over here just now. So it's just pushed, okay? And so this is often the requirement. So you think of this sort of like a Docker hub. So now if you have a teammate who manages running of the experiment, right? Maybe while you are exploring and designing the experiment, someone else handles running for you, you can just say, here it is. Now try to run it for me with whatever infrastructure you have. Maybe run hyperparameter tuning if you want, things like that, which you can just create a large number of them. And I'm going to copy this image name here, which is pretty messy, right? It has all the hash at the end, but there's a value in that, so that specifies exactly this copy of the image, so that the result really can be reproduced. And I'm going to run it I'm going to paste in here. Again, this is my cheat sheet. I already have the command already written down, but we can talk about this a little bit. So what I'm trying to do is I'm going to use the gcloud command. Again, try to run a training job on AI platform, because I don't want to run it on my laptop. I'm going to give you a name called something TF world. I'm going to submit a training job in a certain compute region. I want to turn on compute resources there. And then here's an interesting flag here, master image URI. That kind of ties back to the question you had before, what do you have masters and workers? You can even have different images for a whole cluster of machines if you want. But here I'm just saying I only want one machine that runs this particular thing. And I'm going to, pardon me, specify my model directory to be a Google Cloud Storage location called TF in Docker, maybe TF in Docker 1, why not? Just TF world. And then run 3 epochs. I'm going to run this command and see what happens. I'm going to run it. It's only 3 epochs, so it's not very long, but in the real situation, you probably run it for 300 or something. Okay, so here's command. Once again, oh, it's not formatted correct properly. So I'm submitting a training job, and the only description of the job is just, I don't even upload code anymore because I had already done that. I'm just saying, run this container for me with these parameters. And I expect reproducible results. And it says queued. Well, again, queued where? It's not running my laptop. It's running wherever I submit a job to, which is on AI platform here. Now you see this job that's running. We can go in there and look at the logs, although there's not a whole lot to see because we have seen that many times this evening already. It's going to be exactly the same thing, because literally all this does is that it's going to try to secure some compute resources for me and then run exactly that container. And because the whole environment is carried over, right? Every dependency that we have used in 2 different ways. The local Jupyter lab, when I was doing experimentation, that's in a certain environment. And then when I was testing the scripts outside of here, that's the exact same environment. And furthermore, here, this online in the cloud training job, that's running yet again the very same environment there. So I should expect that to happen very soon. Any questions while we try to see that this really works? Or comments? And if you use Kubernetes, if you already, maybe you and your team already have, say, Kubernetes cluster already set up, you have multiple nodes, that's compute resources for you to use, you can deploy this as well. That's, again, one package that can be moved wherever you want. Minus training data, unless you do things carefully as well. Otherwise, issue. Yes?
Yeah, so say you have a very large data set. Can you have multiple containers running to processing one part of the data set and you can start it, or just a certain amount of epochs and have that basically split the output? How would
Yeah, you can totally do something like that. So the question is, what if you have a really large data set and you want to sort of process different parts sort of in parallel, perhaps, right? You don't care if one part is processed or trained first before another. You can also, again, you don't want to create the same code for different worker jobs there. You might, this is something I was trying to do. I was adding, again, another argument here. I'll say something like data directory or something that I can additionally pass in. And then that way, when I spawn up different containers, I can just pass them different directory target. Maybe there are different directories containing a lot of TensorFlow files, TensorFlow record files, sorry, things like that. Then I can just pass this in. That way, when I create a new container process, again, in the exact same environment, the only thing I want to change is they process different portion of the data or different shard of data. I can pass this in. Okay, probably because of TensorFlow world, it's not running first. But I do want to show you that what happens when this does work is that I expect to see right, what did we pass in before? I passed in this as a target location to write the saved model out to. AI things / TensorFlow in Docker, TFW said this is AI things bucket. And in here, I expect to see a new directory being created that contains the saved model when the job completes and exits, if it would just run. It normally wouldn't take that long. You see in my previous experiments, usually take, it's up to 10 minutes before it completes. But I think the actual running takes some time. So what's happening here is that I specify this new Docker identifier. Remember this long and ugly string here that has this whole hash number, everything. So the infrastructure does have to pull that, the thing I just uploaded somehow. So it's pulling that and then try to run it. So, but we can just let it run and then later we'll see what happens. But I think that about concludes everything I want to show you for this evening. Why don't we switch to a more of a chatting Q&A session if you like, and it's pretty late. If you have other business to attend to, feel free to go attend to them, and I'll be here until 8:30 if you want to chat with me. Thank you. Oh, looks like it's finished. Thank you. So looks like it's finished. Let's actually go here and really quickly see, make sure it saves the file, and now it does save. It does just created this thing here. And that has the saved model for me. And so again, in the checkpoint kind of scenario, you probably write the checkpoints also out onto some storage so that your team can come in and maybe evaluate, maybe figure out how to deploy, maybe continue your experiments for you. Thank you.